Okay, now we're in section 3.4, z-scores and percentiles. So this is going to be on z-score. All right, here's a bell curve. We know lots of things are bell curves. Most of the things we look at are going to be bell curves, so a lot of the theory holds. And here's the mean. And then if I go 1 standard deviation up and 2 standard deviations up, I'm at that dotted line right there. 1 standard deviation down, 2 standard deviations down, I'm at that line right there. All the people outside that range, over here and over here, are unusual. But if you can manage to get into the center of the bell curve, then you count as usual. Okay, so, all right, what's that point right there? Well, if I want to go the mean plus 1 standard deviation, that's going to put me at 69.052. Now I'm within 1 standard deviation of the mean, but I'm allowed to be within 2 standard deviations. I doubled this so that you can see what 2 standard deviations is. 65.714 plus 2 standard deviations, 72.39. Okay, and then if we're going plus, if I'd gone minus right here, I'd have been at 62.376. And if I'd minus this one, I'd be at 59.038. All right, so this was heights, and anyone who's within 59 inches and 72 inches, this is heights for women, any of those people are usual. They don't have anything to worry about. They are usual people. Okay. So then, like, there's this woman, she's like 62 inches, and she's like, that's okay. I mean, I'm usual, because I'm 62. I'm like in here somewhere. I'm kind of on the short side. I mean, did I just barely squeak in, or am I comfortably in there? I mean, I know it's not like that bad. It's not like below 2 standard deviations down, but just, I mean, how bad is it? I'm kind of short. Okay, so she can have her own personal z-score. You can write that formula out if you were the U.S. Census, x minus mu over sigma, if you want. But we're pretending we're in a stats class, so we're doing stats. All right. So her number is 62. And the mean, 65.714. Okay, and divide by the standard deviation, not 2 standard deviations, just 1. And her number turns out to be negative 1.11. So there you go. Not only are you within 2 standard deviations, you're like 1.1 standard deviation. She's just a little bit right there, just beyond 1 standard deviation. You're down by 1.1 standard deviations. You're nowhere near that 2 mark. You're in there. So this tells you how many standard deviations away from the mean she is. Now, yeah, I think I put on here also that if we did something else, we could compare 2 things that don't compare. Like if we had a whole other chart that was all weight, and then she got a similar weight to her height, that's probably a good thing. All right, let's do some more calculations with this. Here's a different mean and standard deviation. So let's get the z-scores for this. This is speeds on the highway. Okay, so the average is 56 with a standard deviation of 4. It doesn't really say what the maximum possible speed limit or legal speed limit is. It just says the average is 56. So the z for someone who's doing 62 is them minus the mean divided by the standard deviation. Okay, so that's 6 divided by 4, so that's like 1.5. Okay, that's entirely usual to be doing 62 on the highway, because it's within 2. Anything that comes out between negative 2 and 2, that's usual in there, and they're at 1.5. So it's entirely usual to be doing a 62 on a highway. 47 minus 56 divided by 4 is negative 2.25. Okay, that's not usual. To be doing 47 on a highway, that's not usual. Okay, they are not within the usual zone. -2, that's out here. -2.25. Okay, you need to stick to surface streets. What about someone who's doing 56? I go 56 minus 56 divided by 4. That's just 0. There's 0 standard deviations away from the mean. Yeah, I could have figured that out. They're at 56, and 56 is the mean. That's why there's 0 standard deviations away from the mean, because they are at the mean. All right, now let's do this one with these tests. Okay, this is the stats test. That's the bio test. There's the mean and the standard deviation for the class. And here's a person who took that stats test. And the means on my test come out way higher than that. Don't worry. Okay, anyway, this person's like way above the mean. So oh, good. And they're above the mean in their bio class as well. Well, which class are they like doing better in? So they could get their own personal math score. 73 minus 63 divided by 7. And they apparently get a 1.43. That is their z-score for their stats class. They're 1.43 standard deviations above the mean. 26 minus 23 divided by 3.9. 0.77. 0.77. They're 0.77 standard deviations above the mean. They're doing great in both classes because they're above the mean, but they're doing really slightly better in their stats class because they're further above the mean. Their z-score says they're 1.43 standard deviations above the mean. That's really good.